Hello everyone. Please type yes in the chat if you can hear me well. Okay, perfect. We will start in 1 minute, okay? Okay. Hello everyone and welcome to the 123rd free webinar titled Oil and Gas Reserve Evaluation, presented by instructor engineer Ahmed Abdulrazak, who is a highly experienced reservoir engineer and certified technical trainer with over 18 years of expertise in the oil and gas sector. His extensive industry background includes working with prominent organizations such as Rashid Petroleum Company, which is Shell JV, EGAS, and international consultancies. He has successfully delivered advanced technical training and consultancy across MENA and Asia for clients including ADNOC, PetroChina, ExxonMobil, and more. His technical mastery spans reservoir characterization, simulation, production optimization, well testing, and integrated field development. With a hands-on approach and strong communication skills, Engineer Ahmed brings deep technical insight and practical field experience to every training session, making him a highly sought-after instructor for oil and gas professionals worldwide. Such a great profile, Engineer Ahmed. But before we start our session, I'll just make a small presentation about OPA. We will have a live course which will be conducted by the same instructor of today's webinar, Engineer Ahmed Abdelrazak, starting this Sunday after 2 days, titled Reserves and Resources Estimation and Classification. You will have lifetime access for the course. You will join WhatsApp technical group if you have any question or inquiry. You will join our ambassadors loyalty program to get more discounts and offers and certificate verification through our website. You can scan this QR code to register in our upcoming course. Don't worry if you didn't scan the code. I'll send all the links on the chat. Here in OPA, we have conducted more than 40 courses, which more than 60 courses, which are now available in as sales in recording courses sales in different disciplines like reservoir engineering, production technology, ring and rigless operations, G&G, safety and analytics. You can also scan this QR code to register. Here is also one of our services, which OPA App Store. They are affordable alternatives for softwares. It was made to save time and money. You can check our apps application on the website, which is opacourses.com. Here is also one of our best services, which is mentorship program. It's one-to-one mentoring session by highly experienced mentors. It's like a tailored program based on the mentee's needs. You can request guiding on personal data, professional guiding for PhD and master, explain the know-how of a software, and so on. We have completed more than 50 mentorship program with more than 950 learning hours. You can also scan this QR code to register in mentorship program. Here is our website, obacourses.com, where you can access everything through it, whether you are applying for mentorship program or internship or enrolling in our recorded or live courses, and also enrolling in our free webinars. Make sure you pay to visit. And finally, how to be an OPA ambassador. There are two tracks. The first one is to take one or more courses or just take a mentorship program. By joining our ambassadors program, you will get discounts on all courses in the future and group discounts when you invite your colleagues. Thank you for listening, and now it's time for our session. Engineer Ahmed, you can start your presentation now.
Okay, thank you. Welcome everyone. I will start to share
Okay.
screen.
Yes, Guru, it's you will get a certificate of the webinar if you joined through website. So everyone, make sure you join through the website to get your certificate. It will be generated automatically tomorrow on the same page on the website. Okay, Engineer Ahmed, you can start now.
Okay, can you see my screen? It is clear?
Yes, we can see it. It's very clear.
Okay, thank you. So our webinar today is oil and gas reserves evaluation. The full course content starting with PRMS and SEC reserve booking guidelines, which is the standard or the guidelines for the resources and reserve classification criteria. We will discuss it. It is a petroleum resources management system to make a common language to make reserves and resources classification. How could we make this as a standard all over the world? And also this guidelines and this standard and this classification, we can apply this also to conventional or unconventional reservoirs. Also in our course, we will discuss reserve evaluation methods, different methods that we can use to estimate the quantities to starting from analog method, volumetric material balance, well testing, decline curve analysis, rate transient analysis, and reservoir simulation, of course. We can use deterministic methods or probability distribution methods. We will discuss all of these topics. Also, we will discuss the factors that affect the reserves calculations and how could we make reserve auditing. And we will discuss also some of economic parameters like payout time, net cash flow, net profit, net present value, the different contract methods that we could apply in petroleum industry. So the whole course are explaining the resources, the reserves, the different methods to evaluate the resources and the reserve, the factors affecting this quantities and these calculations, the standard and the reserve auditing process, and some cases case studies. We will discuss some case studies in reserve evaluation method. For example, how could we use well testing and the deconvolution method in reserve evaluation. We will take some case studies in economic parameters application, also in production sharing agreement. So this is the whole course content today. Inshallah, we will discuss some topics of this course. We will start with PRMS guidelines. Then we will discuss a case study for production sharing contract. And we will explain some of the reserve evaluation methods we will talk about analog method and how could we use pressure transient analysis in reserve evaluation method. And finally, we will discuss the determination of minimum tested volume from the deconvolution in well test process. How could we use this technique to calculate the minimum tested volume? So this is topics today in our webinar. We will start with the PRMS guidelines. Let me minimize this. Okay. So petroleum resources are the quantities of hydrocarbons naturally occurring on the Earth's crust. PRMS, Petroleum Resources Management System, provides a consistent approach to estimate the petroleum quantities, to evaluate the project, and to present the result within a comprehensive classification framework, as we will see. So the definition provide a measure of comparability and reduce the subjective nature of resources estimation method, and are intended to improve the clarity in global communications regarding the petroleum resources. So this classification system of petroleum resources is a fundamental element that provides a common language for communicating both the confidence of a project resources maturation status and the range of potential outcomes to the various entities. So this use of a consistent classification system enhances the comparisons between projects, group of projects, and total company portfolios. So the application of this system, PRMS, must consider both technical and commercial factors that impact the project's visibility and productive life and its related cash flows. The process of estimating oil and gas reserves for a producing field, of course, continues throughout the life of the field. But there is always uncertainty in making such estimates. So if we start with resources, so resources are all the quantities of petroleum occurring on the Earth's crust, whether it is discovered or undiscovered, recoverable or unrecoverable, including also the quantities that already produced. So this is the resources term. All types of resources also meaning all types, whether conventional or unconventional hydrocarbon. So this is the resources. Reserves. So the reserve is the quantities anticipated to be commercially recoverable by application of development projects to known accumulation from a given date forward and under defined condition. So to make it a reserve, to book these quantities as a reserve, they must satisfy 4 criteria. It is discovered quantities, recoverable, commercial, and remaining. So, of course, reserves are a subset of resources. Commercial means that the income from an operation exceeds the expenses involved in or attributable to that operation. So to make these quantities as a reserve, so it must satisfy this criteria. Of course, the reserves are hydrocarbon in place multiplied by recovery factor, and we should subtract the cumulative production. So this is the reserve. Oil and gas reserves are really the cumulative production of a reservoir or field until it is completely developed. So for accounting purposes, they are looking for the produced quantities here. For reserve evaluation and estimation purposes, we are looking for the discovered quantities here. And for resources assessment, G&G assessment or engineering assessment, they are looking for the yet to find quantities of of hydrocarbons. So reserves, again, it is the estimated quantities of petroleum that are commercially recoverable from known accumulation from given date forward under existing economic condition with this price, for example, with this legal conditions, with this existing condition under existing economic condition by established operating practices under current governmental regulations. So it is very important issue to petroleum industry to know the reserves, the anticipated quantities. It's estimation from basis for most development and operational decisions. So to take a certain decision, I should ask what is the reserve, what is the adding value from these activities. So it is critical in financing petroleum development, and it is a key part in policy decisions of also by governments and others. So here we can see the world top 10 reserves holders according to BP, Statistical Review of World Energy, and according to ENI. You will find some discrepancies, small discrepancies. For example, here you will find Iran, then Canada, but according to BP, Canada, then Iran. Also some discrepancies here. Here is US and Libya. Here for ENI, it is Libya and Nigeria. Of course, it is according to the assumptions, the uncertainty, which will be almost all the time. We have this uncertainties in our calculation. So the process of estimating oil and gas reserves for a producing field continues throughout the life of the field. And there is always uncertainty in making such estimates. So according to these assumptions and this uncertainty, you will find some discrepancies here between different calculations for BP and ENI. The level of uncertainty is affected by the reservoir type, the source of reservoir energy, the quantity and the quality of the geological engineering and geophysical data. Do we have 2D, 3D, or 4D seismic, for example? Do we have aquifer support or no? So aquifer performance is a key uncertainty in our reservoirs. Its connectivity, direction, supporting, it is weak or strong. All of this data we need to know. So also the assumptions used when making the estimate, it is also determine the uncertainty in this calculation, the available technology and the experience, of course, and the knowledge of the evaluator. All of these factors determine the level of uncertainty in our calculations. So starting in the early life, in the exploration phase of our field, here in the exploration phase, we will have a very wide range in reserve estimates because we have a wide range of parameters. We have high uncertain parameters. Do you have questions here? Okay. So, but after producing, after putting some wells on production, so now we have log data, we have well-tested data, we have production parameters, we have rate, we have pressures. So we have some additional information. So the range in reserve estimate should get a smaller and smaller range till go to the abandonment. So now we have a very certain values for our reserves. So the magnitude of uncertainty should decreases with time until the economic limit is reached and the ultimate recovery is realized. And this is at the end life of our reservoirs. So we have major standards and practices, international efforts to standardize the definitions of petroleum resources and how resources volumes are estimated begin in 1930s. Early guidance focused on only the proved reserves only. So we have major reserve evaluation and classification practice. We have SEC, which is the United States Securities and Exchange Commission. We have PRMS, which is Petroleum Resources Management System. And we have another standard for Norway, for example, for Canada, for UK, accounting rule. But we will discuss today the PRMS system only. And in the full course, we will also discuss and mention some details about the SEC system. So PRMS is sponsored by Society of Petroleum Engineers, SPE, and approved by the board of the SPE in March 2007, and also sponsored by a lot of organizations and entities for petroleum geologists, petroleum evaluation engineers, exploration geophysicists, and petrophysicists, and well log analysis, a lot of organization. So PRMS provides a resource classification framework for conventional and unconventional quantities. PRMS is a project-based system linking resources to specific development projects. Projects means the activity or the activities that recover petroleum when applied to the reservoir. So the resource classification in the PRMS system depends on the project's chance of commerciality, and the uncertainty in recovery is evaluated also, but evaluated separately from the commercialization risks. So in the PRMS system, we have a range of uncertainty, and we have another chance of commerciality. So test of commerciality should be based on the best estimate of future economic condition, which means the best estimate for the price of the crude, for example. So you should make this test of commerciality. So for PRMS system, as we can see here, this is the PRMS system. It is this figure graphically represent the PRMS resources classification system. So the system classifies the resources into discovered and undiscovered, and it defines the recoverable resources classes. Here we have production, we have reserves, we have contingent resources, and we have prospective resources, and of course we have unrecoverable resources here. Yeah. So we have the total petroleum initially in place, PIIP, discovered and undiscovered. This discovered volumes, we have commercial quantities and we have sub-commercial quantities. So this discovered quantities, we have some of them are produced already, and we have some of them unrecoverable quantities. The rest of them is commercial, which we will call it the reserves. And the sub-commercial quantities, it is the contingent resources. So we will discuss it. So this horizontal line here reflects the range of uncertainty of estimated quantities potentially recoverable from an accumulation by a certain project. While the vertical axis here represents the chance of commerciality, which is the chance that a project will be committed for development and reach commercial producing status. So the total petroleum initially in place is all the quantities of petroleum that are estimated to exist originally in naturally occurring accumulations, discovered or undiscovered. The discovered quantities, the discovered quantity is the quantity of petroleum that is estimated as of a given date to be contained in known accumulation before production. Of course, we will have production quantities, that have been recovered already at a given date. So, of course, as we said, PRMS is project-based classification. So multiple development projects may be applied to each known or unknown accumulation. And each project will be forecast to recover an estimated portion of initially in place quantities. So the projects shall be subdivided into commercial or sub-commercial project, with the estimated recoverable quantities being classified as reserves, contingent resources, or prospective. So reserves here are those quantities of petroleum anticipated to be commercially recoverable by application of development project to known accumulations from a given date forward under defined condition. So reserves must satisfy 4 criteria, as we said, 4 criteria. It is discovered quantities, recoverable, commercial, and remaining. Of course, based on the development project applied. So to make it to make these quantities as a reserve, it must be it must have this 4 criteria, as we said: discovered, recoverable, commercial, and remaining quantities. So to say it is commercial, so we should have a field development plan to book these quantities as a reserve. It must be commercial. To say it is commercial, so this project should have FDP, field development plan, with details that support the commercial claim, which means it will give positive economics, for example. Also, to say it is commercial quantities, so the financial fund are in place or high likely secured. Also, there is a market for sales these quantities, or reasonably will be there, this market to sell our quantities, our petroleum quantities. Also, the necessary production or transportation facilities are available or could be available. And legal, contractual, environmental, government approvals are in place or forthcoming. And financing is reasonably expected to be in place at the time of FID, which is at the time of final investment decision. So this is the criteria to say it is a commercial project and to say it is a reserve quantities. Yeah. So reserve should meet all of these 4 criteria. Of course, this reserve quantities could be further categorized in accordance with the range of uncertainty, maybe sub-classified based on project maturity. But we will discuss this sub-classes in the full course, which is the project maturity subclasses. So reserve quantities may be subclasses to on production or approved for development or justified for development. There are subclasses for this classification, but generally speaking, we have this quantities of reserve should meet this 4 criteria. Okay, so then we have contingent resources here, which is sub-commercial quantities. So contingent resources are those quantities of petroleum estimated as of a given date to be potentially recoverable from non-accumulation by the application of development project not currently considered to be commercial. Yeah, not currently considered to be commercial, owing to one or more contingencies. So contingent resources have an associated chance of development. It may include, for example, projects for which there are currently no viable markets, for example, or where commercial recovery is dependent on technology under development, or where evaluation of the accumulation is insufficient to clearly assess the commerciality. Okay? So under all of these conditions, we will book these quantities, these resources as contingent resources. No viable market. There is a significant risk that a project with reserve will no longer proceed. Commercial recovery is dependent on technology under development. Accumulation evaluation is insufficient to clearly assess the commerciality, or we may have delayed fund, so development will exceed the reasonable time frame, which is 5 years, according to PRMS. So if field development plan will be in place and we will start the activity in this field according to that project within 5 years, so we could classify these quantities as reserve. If it will exceed 5 years, so we will consider this quantities as contingent resources. So according all of this criteria, we will book this or consider this quantities of hydrocarbon as contingent resources, not reserves. Okay. So this is the discovered here quantities of petroleum. Undiscovered undiscovered quantity is the quantity of petroleum estimated to be contained within accumulation yet to be discovered. Yeah. So this is the prospective resources. Are those quantities of petroleum estimated to be potentially recoverable from undiscovered accumulations by application of future development projects. So prospective resources here have both a chance of geological discovery and a chance of development. Yeah, we said before, contingent resources here have only chance of development, but the chance of discovery is 100% because it is already discovered. Yeah, so contingent resources need a chance of development calculations only. But for prospective resources, it is undiscovered quantities, so it needs both a chance of discovery calculation and the chance of development calculation. Yeah. So according to these calculations, we will consider it as a prospective resources. So prospective resources have both a chance of geological discovery, lower than 100%, and chance of development, and also lower than 100%. And we have here unrecoverable resources. It is a portion of either discovered or undiscovered quantities. So, of course, this unrecoverable resources for a given defined project, a portion of these quantities may become recoverable in the future as commercial circumstances change, for example, or technology is developed, or additional data are obtained. So the remaining portion may never be recovered because of physical or chemical constraints representing by subsurface interaction of fluid and reservoir rocks. So we have this recoverable, unrecoverable quantities here. As we said, it is not viable to apply a project with established technology or with technology under development. And it is the quantities for which a visible project can't be defined using a current or reasonable forecast technology improvement. So it is unrecoverable quantities here. We have another term for PRMS system, which is estimated ultimate recovery. This EUR, estimated ultimate recovery, it is not a resource category or class, but it is a term that can be applied to an accumulation or group of accumulations. to define those quantities of petroleum estimated to be potentially recoverable, plus those quantities already produced. Yeah. So estimated ultimate recovery is the production quantities plus the remaining reserve. So this number should be fixed, should be constant with production. So the remaining reserve will be reduced and the cumulative production will be increased, but the estimated or the ultimate recovery will be constant number for certain project. Yeah. So this is the PRMS system, as we said. To summarize all these details, we have here a range of uncertainty, and we have here a range of commerciality. So project resources are initially estimated using the uncertainty range here, horizontal axis. So initially estimated using this uncertainty range forecast that merges subsurface elements together with the technical constraint related to the wells, the facilities. Then these quantities have additional commercial criteria applied to classify the resources to reserve, contingent, or prospective resources. So we have this range of uncertainty, which is categorization for the volumes, and we have this chance of commerciality, which is the classification of this quantities to prospective, contingent resources or to reserve. Of course, there are some details, another details in this PRMS system. As we said, this resource evaluation process is a project-based resources evaluation method. Project means the activities that we will apply to a certain reservoir to produce the hydrocarbon. Yeah. So, as we said, we have always a risk and uncertainty. So we have a risk, which means the probability that discrete event will or will not occur. Will petroleum be discovered? Will the project proceed or not? The uncertainty, it is the range of possible values in an estimate. If the project proceeds, how much will it recover? So we have a categorization here, range of uncertainty, and we have a classification here according to the chance of commerciality. Yeah. So classification approach, which is this vertical axis, classify by a chance of commerciality, a chance of discovery, and a chance of development. As we said, prospective resources needs both. What is the chance of discovery and what is the chance of development? Contingent resources need only what is the chance of development of this defined project. So the chance of commerciality, as we said, chance of discovery is the estimated probability that exploration activities will confirm the existence of significant accumulation of potentially recoverable petroleum. Development is the chance of a contingent resources being brought on stream to produce revenue. So it will be commercially developed. Yeah. So all prospective resources have some risk, which means chance of discovery below 100%. All contingent resources have some risk, which means chance of development lower than 100%. Chance of commerciality, which is the vertical axis, is the chance of that a prospect will produce revenue. It is the product of both chance of discovery and the chance of development to determine the classification of these quantities. Yeah. So, yeah, this is a quick review or a quick summary. There is a lot of details in PRMS system, but we will move to a case study for production sharing contract, because in reserve evaluation and resource classification process, we need a technical and commercial knowledge. Yeah. So here to determine the commerciality, we need to know the revenue. You need to know the capex and the opex, and what is the sharing percent for the contractor or certain company. Should this company invest its money in Egypt or in Iraq, or put it in the bank, or so they need to do some calculations. So this case study, this is an announcement from EGAS in Egypt here, international bid round in 2006. Egyptian Natural Gas Holding Company, EGAS, invites petroleum exploration companies for EGAS international bid round to explore for gas and crude oil in Egypt under production sharing agreement. It is a very common agreement method in the world. There is a tax and royalty method and a production sharing method. So this bid round includes 12 exploration blocks in Nile Delta, North Sinai, Mediterranean. So interested companies can submit their offers based on the procedure, and also based on terms and conditions applied for production sharing agreement. So starting from this date, interested companies are invited to contact the EGAS to purchase the data package and review hydrocarbon potential according to the determined price list. So here you found some price that the company, international company, should take it in its calculations to determine this volumes. It is commercial volumes, so it is reserve, or it is sub-commercial, so it is contingent resources. So data available, coordinates, procedure, and main contract terms and condition could be obtained through EGAS website. So it is you can access this website and found all of this data, of course. So this is a bid round in 2006. This is different blocks in West Delta and Mediterranean, in different. So this is the price list provided by EGAS to the international companies. This is the 12 blocks, block name, area, total seismic survey, data package, and the price of each data. And also EGAS support. This is the data for each block. So for example, this is block number 3, which is North El Maghara. So this is block number 3, North El Maghara. This is the area of this block, and this is the location of that block. This is the coordinate. EGAS gives the area, the seismic surveys, it is a 2D seismic lines. The wells, this block has 3 wells: Bardawil, El Mazar, and Misfak. Previous company was Ayuk and Amoco. Nearby fields and discoveries: El Fairuz, Thiqa, and Tina, Mango oil discoveries. So they mentioned this data, so the investor or the international company can make analog for this block to estimate the quantities, to calculate the anticipated quantities, the anticipated resources in this area, and then make this range of uncertainty to calculate the anticipated quantities of petroleum, and then apply the commerciality test to calculate this reserve quantities. It will be reserve or contingent resources. So every investor, every international company can make a calculation for all of these blocks to choose the best one of them, yeah, according to the data available, the prices, and all of this stuff. So EGAS provided all of this data, so every investor could choose. So here, so this is the prospectivity, for example, for this block. So it is a Cretaceous plays. The main objective of this play are early Cretaceous sand, this sand is tested in Mango offshore well. So the source for this perspective, regional studies in the area indicate mid-late Jurassic and Cretaceous mudstone. So in the geological calculations, they will give a certain number to calculate the chance of discovery. According to the source, it is there or not. According to the uncertainty in charging, in migration path, in sealing, in reservoir, and should I have a trap or not. So according to all of this data, they review all of this data to calculate the chance of discovery and the chance of development to make a categorization and the classification for this block. Yeah. So here they said good sealing capacity are expected and represented by thick shaley carbonate section deposited above the reservoir. So we may have a good sealing. We may have a good charging to our reservoirs. It is highly anticipated that reservoirs in the block area is charged through the planes of deep-seated faults as well as through vertical migration. So they may have this good charging, good sealing, also reservoir and trap. Two main trap types are existed: a structure trap by fault and stratigraphic traps also by shallower sands. And this is for Cretaceous plays and also for Oligocene plays. Also, they mentioned the source, the charging, reservoir, and the trap. All of this data are available for the investors, for the international company, so they could calculate the chance of discovery and the chance of development and calculate the quantities of petroleum. So they could calculate for every block, the reserve in this block is that number, for this block is that number, and they can compare and choose the best block to invest and to make a project. Yeah. So this is another block number 5, North Bor Fuad. Again, the total area, the coordinate. Here is the coordinate for this block, the location. It is located in the eastern part of Mediterranean Sea, North Sinai, water depth. This is offshore. So you have another cost you should consider for your project. As we said, PRMS system is a project-based system. Yeah. So it is applied for certain project. So here you have offshore blocks. So you have a drill ship or semi-sub or jackup or whatever. So it is another cost you should consider. We have here seismic surveys. We have only one well. And the previous companies, BP and IOC, nearby field and discoveries, Bor Fuad, Timsah, Asad, Zaraf, gas discoveries. And again, prospectivity. This is the Miocene anticline structure play, the source, charging, reservoir, and sealing. Yeah, so they provide all of this data. And this is for Pliocene also, the source, charging, reservoir, and sealing. So they offer or provide all of this data to the investors so they could calculate their numbers. And this is the bid round for 2021. So there are another blocks, and also they will provide another sources of data, so every investor could determine, should I take this block in the Mediterranean or this block in the Western Desert or on the Suez Gulf or whatever. So this is according to the PRMS system, which provide a common language system, so they can compare the numbers between different blocks. Yeah. So how could the investors or the international companies make this reserve evaluation? So we have several reserve evaluation methods. We have analog methods. So in the previous slides, to calculate the reserves, so they will need analog. So here you will find they said nearby fields and discoveries. Why they said this? So you can take these fields and discoveries as analog to your block. Yeah. So the first method to calculate the reserve and the resources is analog method. And you may have, you also may use the volumetric estimate method and performance-based method, which is material balance, simulation, decline curve analysis, rate transient analysis. So we will discuss the analog method. So pre and early post-discovery assessments typically are made with analog field project data and using volumetric estimation. But after certain production, so we have production rates, we have pressures, we can use performance-based methods, which is material balance, decline curve analysis, and so on. So generally, the range of estimated ultimate reserve is expected to decrease as more information become available. Yeah, of course, this is not always the case. In each procedure, the results are not single quantity of remaining recoverable petroleum. Yeah, but rather a range. Why range? To cover all the uncertainties. Yeah, uncertainties in place quantities and in the recovery efficiency. So the confidence in assessment results generally increases when the estimates are supported by more than one analytical procedure. Yeah. So we should calculate the reserve by all the available methods using the analog, the volumetrics, the material balance, the reverse simulation. So you will have a high confidence assessment using more than one procedure. Yeah. We will cover analogs. Analogs are widely used in resource estimation, especially in exploration and early development stages. So direct measurements information is very limited. Yeah. So this methodology is based on the assumption that analog reservoir is comparable to the subject reservoir in regard to reservoir description, fluid properties, and in recovery mechanism, in aquifer performance. So by selecting appropriate analogs where performance data of comparable development plans are available, a similar production profile may be forecast. So analogs are frequently applied for aiding in the assessment of economic producibility, production decline characteristics, drainage area, recovery factor for primary, secondary, or tertiary methods. So analogs reservoirs are defined by similarities of features and characteristics between the two fields or the two reservoirs in reservoir deposition and structure, in reservoir condition, depth, pressure, temperature, aquifer performance, fluid properties, drive mechanism, petrophysical properties like net pay, gross thickness, porosity, saturation, permeability, and also in the development plans, which contains well spacing, well type and number, completion methods, artificial lifting. So you should, the comparison to several analogs rather than a single analogs often improves the understanding of the range of uncertainty in the estimated recoverable quantities from the subject reservoir. So for example, here you may have this is some data or some trends that help in choosing the best analog reservoir. So you should consider the cumulative gas and the maximum gas rate. You should consider the air permeability and the porosity for all your existing fields. So you can choose the best analogs for your desired field according to this available data. So you will take all the data from the analogs reservoir and apply this data to your current reservoir. Yeah. So here, for example, you will take the time depth curves. For example, the drilling a well, taking how much days, for example, will take 30 days. So you could calculate the cost of drilling and complete a well. You could calculate the total the time needed here. Here is the phase time analysis, rig move, jetting, 36 conductor, drilling, all of this data. So you could this data for analogs reservoir or analogs field will help you to estimate the cost in your current field to make this analogs. Yeah, here is the phase cost analysis, for example. This is by days here, how many days for each phase, and this is by cost. So analog method is applied by comparing the following factors for the analogs and the current field: the recovery factor, the barrel per acre foot, and the estimated ultimate recovery. The recovery factor of a close to abandonment analogs field is taken as an approximate values for another field. So similarly, the barrel per acre foot is assumed to be the same for the analogs and the current field. So we can compare the estimated ultimate recovery during the exploration phase. So of course, as we said, analogy is most useful when running the economics on a yet to be drilled exploration well. For example, care should be taken to make sure that the field or well being used for analogy is indeed analogs. Yeah. So Dolomite reservoir with volatile crude oil will never be analogs to a sandstone reservoir with a black oil. Yeah. So also, if your calculated estimated ultimate reserve is twice as high as the estimated ultimate reserve from the nearest 100 well, so you need to check your assumptions and your analogs well. So regardless of the analytical procedures used, the goal is to communicate the range of uncertainty in the recoverable resources. So an underlying principle is that the reliability of the estimates depends on the quantity and the quality of the data. So in all the resource assessment methods, as confidence away from a non-productive area decreases, the uncertainty in the ability to estimate recoverable quantities increases. In assessing the range of uncertainty in recovery from a project, the evaluator should consider the uncertainty in all components of a project, including, of course, that forecast from existing and future wells. So we may use deterministic method or probability distribution method to cover all the uncertainty in porosity, for example, in permeability, in aquifer volume, in aquifer direction, in gas-water contact, in transition zone, capillary pressure, relative permeability. All of this data, we have uncertainty in all of this data, especially in the early stages in the field. Yeah. So we need to cover all this uncertainty. So we may use deterministic method or probability distribution method. Deterministic method, the quantities are estimated by taking discrete values for each parameter, for each input uncertain parameter. For example, for the porosity. In the calculation in volumetric method, for example, volumetric equation, instead of using one value for porosity, I will use 3 values and calculate 3 numbers, yeah, to cover the downside risk and the upside potential. So I will use, for example, porosity of, for example, 15 and 17 and 21, yeah, to cover all this range and calculate 3 numbers of in place. So this is a deterministic method. So here, for example, for permeability, mechanical skin, rock compressibility, I will use 3 numbers in the deterministic methods, 3 discrete numbers, yeah, to calculate 3 values for in place and also for reserve. The other method is the probabilistic method. In this method, the evaluator define a distribution which represent the full range of possible values for each input parameters. Instead of give a discrete values, no, I will give a probability, a range of possible values. So this distribution are randomly sampled using, for example, Monte Carlo simulation to compute a full distribution of potential in place and reserve quantities. Yeah. So, of course, this approach is most often applied to volumetric resources calculation in early phases of exploration. And the outcome of this is the B90, B50, and B10, which is proved, probable, and possible reserve, or low, best, and high estimate, or downside risk, and best estimate, and upside potential, whatever the name of it. So, as we can see here, for the volumetric calculation for beta O, SW, porosity, area, net to gross, we will make it as a range, yeah, a distribution. So I will end up with a range for original oil in place. So I will take a proved here and proved plus probable and 3B here value of original oil in place. So why we need this? Because porosity, for example, we don't know what is the range of porosity. We don't know what fills this porous rock. It is hydrocarbon or water. We don't know the aerial quality of the rock. We don't know the rock types. We don't know. A lot of uncertainty. So we need to cover all of this using the distribution. Yeah. So this is, we need to assess all possible scenarios in any pre-drill prospect. So we need to sorry. So explore the full range of knowns and unknowns by giving a low and mean and high probability distribution using all the possible values in the calculations. Yeah. So we may have different shape of distribution for each parameters. For example, we may have for uniform distribution, which means the same values. We may have a triangle distribution. We may have a normal distribution, log normal distribution, whatever the distribution. We will provide this distribution to the software, and the software will use this distribution for every input parameter in the calculation process. Yeah. So we may have the mode, median, and mean here. Of course, the distribution, as we said, we may have symmetric, which is the bell curve, or we may have normal distribution here. We may have left skewed or right skewed distribution. Whatever the distribution here, we will provide this distribution to the software. So Monte Carlo, for example, you can find this simple calculation in MBAL, in material balance software. It contains this Monte Carlo simulation. It is a technique used to evaluate the hydrocarbon in place. So each input parameter, we will provide it with its distribution to calculate the reserves and the three numbers B10, B50, and B90. So this is a simple window for this software. So here we will provide it with the BVT data here, and we will provide it with the distribution for every parameter that used in the volumetric calculations: area, thickness, porosity, saturation. So I may give it as a fixed value or a uniform values here according to different probability distribution, fixed values, uniform distribution, triangle, or whatever. Here, normal distribution or log normal distribution. Then Monte Carlo will calculate this curve here. So this is the oil in place, and this is the CDF or cumulative distribution function there. And software will provide me with the B90, which is proved reserve, B50, which is probable reserve, B10, which is possible reserve for oil and for gas, of course. Yeah. So this is a simple Monte Carlo calculations to cover all the range of uncertainty here. So it will provide me with this three numbers to cover all the range of hydrocarbon. So this is how could we make categorization or range of uncertainty of our project. Another topic is using well testing in reserve evaluation. Could we use well test in reserve evaluation? The answer is yes, of course, we can use it. Of course, well testing is a tool for reservoir evaluation and characterization. It will discover a much larger volume inside the reservoir than the cores or the logs. In this tool, well testing, we will make a signal inside the reservoir and we will receive the response of the reservoir, and we can find a lot of information, useful information from this response. We can use well testing in reservoir description, compartmentalization, to cell or radial composite, estimate average reservoir pressure, provide estimate of permeability. We can also use this well testing in hydrocarbon volume from reservoir limit test, as we will see in the upcoming slides. So, of course, we should design a well test if we needed to calculate the reserve. We should design it to flow to reach the boundaries. So we can use this test to calculate the connected volume or the reserve in this area. And we can construct the B over Z versus cumulative gas plot for gas fields and calculate the gas in place. So here we have reservoir limit test. So if we look at the pressure response in the well producing with constant rate, we would see that the pressure continues to fall as the well is produced. The pressure falls rapidly at the starting, but eventually the pressure starts to fall linearly. So a steady pressure decline per certain volume of production. So this linear fall of pressure is the pseudo-steady state condition. Yeah. So we will start here. If we record the BWF versus time, we will start with transient flow, then late transient, then when the pressure signal reach all the boundaries, we will follow the semi-state or pseudo-steady state condition here. So we will have a linear relation between the BWF and the time. From this linear relation, we could calculate the volume. Because we have partial B by partial T here, it is a function in the pore volume there, yeah? And we have this constant decline, so we can determine the pore volume and we can determine the reservoir volumes. So some mathematical calculations starting from compressibilities, but we can end up with this relation, partial B by partial T. It's a function of rate, which is constant, compressibility, total compressibility, and we can calculate it, and the pore volume, so we can calculate the pore volume and the in place. So here, examining this equation reveals the following important characteristic of the behavior of pressure decline rate. There is a pressure decline at a higher rate with increasing the fluid production rate, of course. As you increasing the rate, you will have a steeper or a much higher declining. Reservoir pressure declines at a slower rate for reservoir with higher total compressibility coefficient. Also, the reservoir pressure declines at a lower rate for reservoirs with larger bore volumes. Yeah. Of course, if you have a water influx, you should add this water influx here. So water influx will support the pressure and decrease the decline rate with production. Yeah. So simply in reservoir limit test, just make a graph between flowing pressure and flowing time. So you will have a straight line here. So you could calculate the slope of this straight line, and from this slope you can calculate the pore volume. It is a simple direct calculation. So also I can use the well testing in calculating the volumes using the gas material balance. So for gas wells here, if we have 2 points of pressures here and we have the cumulative of the gas, we can construct this B over Z and calculate the original gas in place using B over Z material balance plot. So, of course, we need 2 pressure build-ups with certain productions to construct this material balance plot. But of course, well testing have some challenges, non-uniqueness of pressure transient analysis, PVT probabilities accuracy, of course, choosing the best correlation to calculate the beta O and the total compressibility, low permeability reservoirs prevent pressure disturbance wave to travel fast enough to reach the boundaries and the other wells. And of course, the software that you should use. So well testing have some challenges in this calculations. Finally, we have this method. We have this SPE paper by Tim and by Alan Gringarten in the Imperial College. How could we determine the minimum tested volume from the deconvolution of well testing pressure transient analysis? Yeah. Of course, deconvolution is a mathematical method that represent all the history as a constant flowing drawdown pulse. So we could convert all these changes in production and pressures to only a single fixed rate with a single pressure decline. So converting this different production and pressure to certain single production rate is a deconvolution mathematics. Yeah. So what is the benefits behind the deconvolution? If you make analysis for this build up end at this 2008 hour of starting production. So if you make it a deconvolution, it will give you a signal for the whole history. If you make a build-up analysis only for this period, normal build-up analysis will give you the signal inside the reservoir, radius of investigation inside the reservoir for only this period. But if you use a deconvolution method, you will have a pulse inside the reservoir for all the history, for all the production history. So it will go deeper and deeper inside the reservoir. Yeah. So what is the benefit of it? We can use it to calculate the minimum tested volume. So a well flowing in a finite reservoir will finally reach a pseudo-steady state condition. So the pressure respond according to material balance rules. The time to reach a pseudo-steady state depends on the diffusivity of the reservoir, the distance from the well to the further boundary, and of course the effect of the other producing wells. Pseudo-steady state will always be the last flow regime. Yeah. So we have the material balance calculation. It can provide estimate for average reservoir pressure and the volume of fluid in the reservoir that are connected to the well. We can apply in practice. Of course, except extended well testing or for very small reservoirs. In practice, well tests are not long enough to reach this pseudo-steady state, so it is not possible to calculate the total connected volume. Instead, a minimum tested volume is calculating using a technique described by various authors. So these techniques sometimes referred to as a shrinking box method. So what is the shrinking box method? So here, imagine we have this response. This is the end of measured data, and this is the build-up analysis for certain well. So it requires the selection of a model that applies to the entire observed transient response that give us the same derivative here. Here we have, of course, the pressure derivative. So the model is bounded on all sides, and the distance to the outermost boundaries are reduced, which is LF here. I will reduce LF here until they just start to have an effect on the pressure transient response here. Yeah. So this is the end of measured data. We have here, this is the dB, a flat line, and this is the half slope. Half slope means we have a channel reservoir. Yeah. So we can calculate the W, the width of the channel. So where is the uncertain parameter? It is the LF, the length of the channel. Yeah. So if we choose a very small LF, so LF too close will have this deviation from the measured data. If we have LF very large, so we will have far away here, unit slope. So we will reduce the LF till it will start from the end of the measured data. So it can then be confirmed that the connected volume must be greater than or equal to this volume, calculating using this W and this LF. I hope it is clear, yeah? So we will reduce this LF till it will start from this end of measured data. So this is the minimum length of the channel. And we can calculate the volume according to this minimum volume, yeah? So here we have a drawdown and build-up derivative. Of course, when we have pseudo-steady state, the build-up analysis will go down and the drawdown analysis will go with unit slope. So this is the range of pressure transient till this period. And starting from here, it is a pseudo-steady state unit slope response. So using the deconvolution give us a constant drawdown effect, yeah? So if this is a build-up analysis, if we make a deconvolution derivative, it will be for the long full history. So it will go deeper inside the reservoir. So I will assume that the unit slope will start at this final measured point, yeah? So now I have delta B derivative maximum and delta T maximum. And I will assume that the unit slope will start from this point. I will take these two values, delta B derivative and delta T, and I can calculate using the same equation for reservoir limit test that we just described in the previous slides. I will use the same equation using delta B derivative and delta T, and I can calculate the VR, which is the minimum connected reservoir volume, and we can calculate the minimum oil in place using this method, using shrinkage box with the deconvolution. So this is the summary of this SCBE paper, which is very useful paper, really. And of course, we can add the uncertainty inside this method. So here we have example here for gas field. This is the final measured point, and we used this method to calculate the in place, which is 3.5 PCF. Here we have another oil example, and here we have some uncertainty in the initial reservoir pressure. So we applied this uncertainty and we end up with three numbers here for oil in place. So we have B90, B50, and B10 from this minimum tested volume method. Yeah. So this is concluded our webinar today. I hope you found it useful webinar. I'm happy to hear your questions, recommendation, feedback, or any other ideas.
Thank you, Engineer Ahmed, for this fruitful session. It was really enjoyable.
Thank you.
We will have 2 minutes to receive the attendees' question. Please, if you have any question, please type it in the chat so that Engineer Ahmed could answer them. Thank you.
Okay. Let's see the chat. Thank you. Thank you. I'm happy to hear this from you.
Okay, I think we don't have any questions. This is a gentle reminder of our next live course, which starts this Sunday in 2 days, which titled Reserves and Resources Estimation and Classification. It will be conducted by the same instructor of today's webinar, Engineer Ahmed Abdelrazak. So just contact us through any of our social media channels to enroll in this course. Thanks for attending and see you soon, inshallah, on our next webinars. And special thanks to Engineer Ahmed for this fruitful session. Thank you. I'll ask Engineer Ahmed to share the presentation with us, and we will share it on the website.
Okay, I will do. Okay.
Okay, thank you.
Thank you. Thanks for all of you. Hope you all the best and see you, inshallah.
Inshallah.